organic synthesis, NMR spectroscopy, and chromatography, right?
Yeah.
Okay, fine. So first we'll have a quick revision of all the things we have done till now, okay? We'll start with, what do you understand by homologous series?
A homologous series. Um. So yes, it's just like a family of all the hydrocarbons.
Only hydrocarbons?
I mean, yes, it's just hydrocarbons which share like a similar properties, basically. That's it.
Okay, they contain same functional group. Okay,
Yeah,
so
group.
how
Yeah.
can I put it that homologous series is, as you said, it is a family of organic compounds containing the same functional group. Okay, this is the same functional group.
Yeah.
Okay. Now, if I'm talking about a functional group, can a functional group be changed?
Yeah. That's through substitution.
Change. Okay, there can be substitution, right? So
Yeah.
functional group in an organic compound may be changed into another functional group, right? Okay.
Yeah.
Third point is we are talking about organic chemistry, okay? Organic chemistry, they require reagents. What do you understand by the word reagents?
Reagents. Yeah, they
Yes.
just I think they react together to create a product, basically.
Okay, so that is my third point. Organic chemistry requires reagents used. Okay, fourth.
Yep.
Okay, have you done infrared spectroscopy before?
Yeah.
Okay, what do you
But
know
like
about them?
very briefly, if you did it.
Very briefly, you have done?
Yeah.
Okay, so if you have known about them, we can say infrared spectroscopy and mass spectrometry. Okay, they are
Yep.
used to analyze and identify an organic compound, right?
Yep.
Okay, also infrared spectroscopy. If we are talking about infrared spectroscopy, they will be used to determine the bonds. Sometimes they are used to determine the bonds present, right?
Yep.
And the fingerprint scanning was due to this. Fingerprint sensor or fingerprint region, we can say. Okay, they were used to
Yep.
identify a compound. When I'm doing mass spectrometry, they are used to determine the molecular formula of a compound,
Yep.
right?
Yeah.
Okay, so this is a small revision. Okay, now before starting with organic synthesis and all, I have to give you, I'll be giving you a few questions which I need you to answer. Can you do that?
Yeah. Let me try.
Okay.
But once
Simple ones, don't get scared.
yeah.
So I'll put it in the next slide.
All right, let me try that.
Okay, these three questions, simple ones, I think.
Okay. I'll just write it on a piece of paper first, and then I'll send it.
Okay, fine, no issues. You can do that.
It's just a bit easier. Really done. But for the last question, question 3,
Okay.
due to the how you meant to know that? Identify the alkene which has it at MZ42.
Have you done before these kinds of question?
Not the last one, but I've done all the other ones.
Identify the alkene which has a peak due to its molecular ion at MZ42. Okay, you have not done this, right?
No, not yet.
No issues. If you have not done this, no need to answer. Okay. I thought you must be knowing it. That's why I asked you this question. Okay. Other ones were you able to
Yeah,
name
I've already
before?
done
Okay.
that.
Can you tell me
Yep.
the answers?
The first one is acetic acid,
Okay.
then propane nitrile,
Propanitrile. Okay.
Then pentantuone,
Sorry, what was it?
pentantuol, tuone. There's a
Okay,
ketone. Yeah.
okay.
Methyl acetate,
Methyl acetate,
propanol,
propanol.
and butene.
Okay. Second one,
That's the C double bond O,
C
first one.
double bond O.
Then it's the OH, which is for that one.
Okay.
And then it's C triple bond N.
C triple bond and cyanide group, right?
Yeah.
Okay, fine. Now, so you know bit of what we're going to deal today, organic synthesis and as well as spectroscopy, right? So
Yeah.
we'll start with what is organic synthesis. Okay, now organic synthesis is just another branch of chemistry. Okay,
Yeah.
like we have organic chemistry and also organic synthesis also falls under that. And now this organic synthesis is concerned with the producing of organic compounds.
Yeah.
Okay, producing of organic compounds by chemical reactions,
Yeah.
simple chemical reactions. Okay. Now there was a scientist, an American scientist named as Robert Burns, and he is regarded as the father of the modern organic synthesis. Okay. He was awarded the Nobel Prize in 1965. Is it necessary? Okay, this is just for your information purpose. Okay. But why did he get this Nobel Prize was because he synthesized many natural products such as cholesterol. What is cholesterol?
What is cholesterol? uh,
Where have you heard the word cholesterol?
I read in biology, but I don't do biology. uh,
Okay. But simply, even if you're not doing biology, cholesterol is a very common word.
yeah, it's just that fatty substance. That's it.
Unwanted fatty substances, right?
Yeah.
Which gets settles down in the body is known as a cholesterol. Chlorophyll is also a green pigment which is
Yeah.
used by the plants, okay, to produce their food. Quinine and cortisone are some chemical substances, okay. So this
Yeah.
scientist, he synthesized these natural products and hence he got a Nobel Prize very recently, like in 1965. Not very recently in the sense, but in the 19th centuries.
Yeah.
Okay. Now, the synthesis of organic compounds, what do they need is they need functional groups. And what are functional groups?
Well, all those things.
Name me some functional groups.
Alcohol, ketone, aldehyde, carboxylic acid.
Okay, so these are the functional groups. So what does organic synthesis does is organic synthesis compounds, it requires one kind of functional group to be changed into another functional group. Okay,
Uh,
if suppose
yeah.
I have an alkene, let's start with a simple one. Okay, now alkene can be converted into an alkene, alkene can be converted into an alcohol, right?
Yeah.
Then alkene can be converted into an halogenoalkene. Then from this alcohol, I can still modify them into an aldehyde,
Yeah.
right? This
Yeah.
aldehyde, I can convert them into a carboxylic acid.
Yeah.
So this continues, right?
Yeah.
From a simple one, we get many links like this. Okay, from one functional group to another, one functional group to another. So, organic compounds is undergoing this change. Okay, now what happens here is whenever they are changing, they change in terms of reagents, they change in terms of conditions, they change in terms of mechanism, also the type of reaction. Okay. So these are the
Yeah.
methods which also undergo change whenever the functional group is undergoing a change. Okay.
Yeah.
Okay, write it down and then I'll move on to the next sheet.
Okay. Yeah, done it, yeah.
Done?
Yep.
Okay. Now what I'm going to show you. Okay. This is a summary of organic reactions, the one which I was talking about, like how
Yeah.
alkene is converting into halogen or alkane, amine, nitrile, everything. So what I want to do is I want you to either save it or take a screenshot of it and save it, because with the help of this we have to study many things. Okay.
Yeah.
Also there will be questions regarding this one. So what do you want me to, what do you want to do? Are you going to write it down? You're going to save it somewhere? Anything?
I'll take a screenshot of this.
Okay, fine.
Yeah, it's a bit too much to write.
Yes, I know.
Yeah, I've taken the screenshot. Yeah.
Taken. Okay, I have to give you one more. Have you got another one?
Yeah.
Okay.
Let me screenshot
And
that.
also,
Wait, let me do that.
yes.
Yeah, taking it. Yeah.
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 One more coming up.
Yeah, taken again. Yeah.
Done.
Yep.
No, now this one you have got. The next one, next set.
Yeah, I've taken that one. Yeah, I've taken that.
Okay, fine. Remember, now we are going to deal with some question sets which requires all these in hand. Okay?
Yeah.
Okay, fine. Now, with the help of these tables and the explanation, that means we have example, reagents and the conditions, okay? There might be
Yep.
questions, sort of. Question number one, ethanol may be converted into, okay, this is the question.
Yep.
Now, what does the question say? Ethanol may be converted into bromoethane. So, we are converting ethanol into bromoethane using a three-step synthesis. Okay. So, the first
Yeah.
step, what is happening? Ethanol is being reduced. Okay. Here, the term is reduced. Compound A. Then, compound A is then converted to compound B. Compound B is then converted into bromoethane. Give
Yep.
names of compound A and B. For each step, list a reagent which could be used and name the mechanism. Okay. So how
Yep.
to start solving this? First, we have to identify the homologous series of the starting product. Okay. Now, what is my starting product here? Ethanol.
Ethan,
Okay. Now, ethanol belongs to which homologous series?
the aldehydes.
Aldehydes. Okay. And what about my final compound? What it is? It is a bromoethane.
Yep.
Bromoethane is a
Alkane.
alkane,
Halogen.
halogenoalkane. Okay. Ethanol is
Yep.
aldehyde, bromoethane is an halogenoalkane. Okay. Now, they have given us some clues over here. What is a clue? First step, they have said that it is reduced, right?
Yeah.
It is reduced. Now, if you go to your sheet where I have given you that synthesis, the shorter ones, the one
Yeah.
with the arrows, and
Let me just
you
see
have
that.
it, yeah. Open that sheet. Now, with the help of that, we will see what how it is formed.
Let me just open that side by side so I can see. Let me just see. Is it the first page of the sheet or the second page?
The one with all the arrow marks, summary of organ.
Oh, that one. All right.
Yes,
Yeah,
that one.
yeah, I can see it now. Yeah.
Got that? Okay. You
Yep.
just have a look over that. Okay. They have said it has been reduced, right? It is reduced.
Yeah.
Aldehyde has been reduced to alcohol. No, no. Aldehyde is been reduced to a compound. Which compound? And that is again converted into another compound and then to aldehyde. So I think you will have this one. Okay, let's start with aldehyde. I'll put aldehyde over here. Okay, aldehyde. Okay, it has been reduced to a compound. Okay,
Yeah.
I'm moving from the first one. This compound is again reduced to another compound, right? And this
Yeah.
compound gives me halogenoalkane. Okay, do you see a link with this? Aldehyde giving something, and then to halogenoalkane. So you have a lot of arrow marks here and there, right? Okay.
Yeah.
When you go to aldehyde, what I see is aldehyde giving hydro hydroxynitrile. Okay. The above
Yeah.
arrow goes as hydroxynitrile. Then I have carboxylic acid, right? So I'll just write here. The other options which I have is hydroxynitrile, and one more I have is carboxylic acid, right?
Yeah.
Now and one more which I have is a alcohol.
Yeah.
Okay, these are my options. Okay, let me check. Hydroxynitride, if it is getting reduced, I am not going to get a ketone, right?
Yeah.
Okay, so this option is gone. Carboxylic acid. When I'm going to reduce my carboxylic acid, I will be getting an ester. Okay, but if I convert the ester, I won't be getting a halogenoalkane because none of my arrows is giving me a halogenoalkane. So again, this option is dropped by. Moving on to alcohol. Okay, alcohol. If I'm going to reduce alcohol, I have three options. Alcohol will get reduced. Either they will convert it into an alkene or they may convert it into halogenoalkene, right? Okay.
Yeah.
First option will take them as alcohol because we are getting a conversion. Now this alcohol is converted into some other homologous series and then to halogenoalkane. So if you have a look at this, what follows the path is this. So alcohol getting converted to alkene, alkene getting
Yeah.
converted into bromoethane. That is a halogenoalkane,
Yeah.
right?
Yeah. I got that. Yeah.
Is when you have the synthesis format with you, when you can actually identify which is getting synthesized where.
Yeah.
Okay, this is one method using that. Now the other method, step one. What is step one? Ethanol is reduced to compound A. Okay, so compound A, ethanol. Ethanol is reducing to ethanol. Whenever we are reducing any aldehyde, what do we get is an alcohol. So compound
Yeah.
A, we have found out it is a ethanol, right?
Yeah.
This is an alcohol and this is a ketone, I mean alkene. But what is the
Yeah.
name of the compound? So we have found it is an ethanol. Okay, now ethanol is getting converted to compound B, which is an alkene. Since we are talking only
Yeah.
about ethanol, my alkene will be nothing but ethene,
Yeah.
right? Then
Yep.
ethene is being converted to what is my final compound? Bromoethane. So we have found all of them.
Yeah.
Okay. Now we can use this with the help of the tables provided also.
Yeah.
Okay, ethanol conversion, ethanol Reducing to ethanol is there on uh, table number 17. Okay, the table which you have. Okay, the 17th point is conversion of ethanol to ethanol, that is aldehyde to alcohol. Then from ethanol to ethene, I think the reaction 12, alcohol
Yeah.
to ethene. So mention that number also, and you please refer the table, the numbers, then you will identify them better. And the last one is reaction 2, where an alkene is getting converted to a halogenoalkene.
Yeah, I made a note here. Yeah.
Done with that?
Where, one sec, I'm just writing down last thing. Yeah.
Okay. In the next set question. So these are the steps, okay? We have a compound A. Step 2, I have compound B. Step 3, I have this is my compound C. Okay, whenever they're asking the question like suggest a reagent and name the mechanism, you have to refer the table and you have to answer them. Okay, this is a question. Now, how to do it? I'll help you with this one. Okay. Now, which which homologous group does this belong to?
Let me see. Propane, so that's alkenes, yeah.
Propene is an
Alkene.
alkene. And the last compound
Last compound, that's a nitro.
is a hydroxynitrile.
Yeah, yeah.
Okay, so we know propane is getting converted to hydroxynitrile with two different compounds in middle, right? So
Yeah,
compound C is hydroxynitrile and they have been formed from, basically they are formed from an aldehyde and ketone. Okay,
yeah.
have a look at, you have still have the markings with you, the organic synthesis one.
Well, one sec. Sorry.
Just check the arrow ones. Okay, I'm talking.
Yeah. Let me just check that. From a alkene. So where's an alkene?
No. What I've said was check where is hydroxynitrile.
All right. Yeah, it's right
Okay.
in the middle. It's
Yeah,
like
it's right
next
in the
to
middle. Now, hydroxynitrile can be made from either an aldehyde or a ketone.
a ketone. Yeah.
Okay, we have two options. So, my compound B will either be a aldehyde or it must be
Yeah.
a ketone. Okay,
Yeah.
so I don't think so. It will be a ketone. Let's stick with aldehyde, okay? Because when I'm looking at the diagram, ketone is not getting reduced to alkene group from alcohol and all. So I'll stick with aldehyde, okay? For time being, let's consider this is an aldehyde because I have two options. For time being, let's consider my B is aldehyde, okay? Now, propene is an alkene, right? And what connection do you have from aldehyde to alkene? What is the another homologous series which fits into it?
Aldehyde to alkene. Let me see where. The where is alkene? Alkene. So aldehyde to alkene. That goes for alcohol.
Okay, so compound A is my
Yeah.
alcohol. Even if you go via ketone, you will get the same thing, I guess, right?
Yeah.
Hydroxyl ketone gives me an alcohol, and alcohol gives me a alkene.
Yeah. Yeah.
Okay, for time being, we'll consider aldehyde. If not, it is an aldehyde, we'll jump on to ketone.
Yeah.
Okay, now let's see how are now we have got this, right. A will be an alcohol, B is an aldehyde. Now if you go to the table format, you have a, according to the table format, if you see, there will be conversions, so each number representing alkene to alcohol and then alcohol to aldehyde, aldehyde to hydroxy nitrile. Okay, now let's
Yeah.
see what are the reaction cues. Now I am not mentioning you the reagent and the mechanism, you have to identify with the table number I'm giving you. Okay,
Yeah.
so this is propene compound A, sorry, propene is my starting agent and it is getting converted into alcohol. So propene, when I'm going to convert, it will be nothing but propane 1 all, right?
Yeah.
It will be propane 1 all. And according to the table, what I can see is you check the table of 4 and tell me what will be the reagent and the mechanism. Okay. Next conversion is from propanol. I am going to convert it to an aldehyde. So propan 1 all converting into an aldehyde will be simple. That is propanol. Right?
Yeah.
Simple conversion. Propan 1 all alcohol to aldehyde will be propanol. And this is reaction number 14. Check reaction number 14. Then propanol into hydroxynitrile. Now hydroxynitrile, the compound, right?
Yep.
So propanol, when it is getting converted into hydroxynitrile, okay, compound C, the name here is 2-hydroxybutynitrile. 1, 2, 3 carbon atom, right?
Yep.
3 or 4 carbon, 4 carbon atom. So the name will be 2-hydroxy butynitrile. If you want, you can check reaction number 19. Now check the table and tell me which are the reagents and what is the mechanism used here.
Right, let me check. Number 19 is aldehyde ketone to hydroxynitrile. So the reagent is KCN. So it's potassium cyanide.
Potassium.
And that's nucleophilic addition.
Which one?
Yeah, for the 19, or for number 19.
Go from the top one, 4, 14, 19.
Wait one sec. Yeah, yeah. So all it says for that is that aldehyde slash ketone, it goes to hydroxynitrile, then that goes on to CH3CHO plus HCN. That goes to
Okay, let me read out to you. Reagents used here, when I'm talking about equation 4, the reagent is water.
oh, you mean equation four? Oh, sorry, right.
Yes,
Yeah.
and the
All right.
mechanism used here is electrophilic addition.
Yeah, electrophilic. Yeah, for number 4. Yeah.
Yes,
Then for 14, that is acidified potassium dichromate, and that has no mechanism.
no mechanism. Okay, 19th one.
19th one, that is KCN, and
Okay,
that's nucleophilic addition.
nucleophilic addition. So you understood how is this happening?
Yeah.
To refer both the tables, the one with the arrow mark one, okay, the summary one, and the table. With the help of these two only, you can identify the answers over here. You understood how I'm getting this?
Yeah, I got that. Let me just screenshot this so I know the steps. Yeah.
Done?
Yep.
Okay. Now I'm giving you something to solve. Let's see whether you can do it. This is the first question. Second one. Third one.
You are currently the only person in this conference.
தக்காளி அதுக்கப்புறம் வந்து தேங்காய் தண்ணி ஜீரகம் இதெல்லாம் சேர்த்து மிக்ஸ் பண்ண சொன்னாங்க மிக்ஸி நிற்க மாட்டேங்குது இது இது திருப்பி போட்டா எல்லா வாட்டியும் போட்டு பத்தலன்ட்டாங்க எவ்வளவுதான் அரைச்சாலும் பத்த மாட்டேங்குது பத்தலன்னு சொல்லிட்டு நான் மிக்ஸி அடிச்சுட்டே இருந்தேன் அதுக்கப்புறம் நல்லா கன்சிஸ்டன்சி வந்துச்சு அடுத்து
நெய் எங்க இருக்கு ஐயோ சமையலை பத்தி நமக்கு தெரியாது நெய் எங்க இருக்குன்னு தெரியல
You are now muted.